Okay, today we're going to talk about how to compare sets of data. And we can look at different measures of central tendency. So you could be asked to simply compare the mean, median, or mode, in which case you'd find the measure for each one and compare them, meaning talk about if they're close to the same thing or how they're different. If you're asked to compare the variability, then you need to find the IQR. Remember, the IQR stands for interquartile range. All right. The more spread apart the data are, meaning a larger interquartile range, that means the more variable they are. The less spread apart they are, the more consistent. So we're going to look at how to solve and interpret data. Okay, right here, it says students at 2 middle schools sold reusable bags to raise money for Earth Day. Nellie surveyed a sample of 10 students from each school to find out how many bags each student sold. Her data is shown in the stem and leaf plot. Now to read a stem and leaf plot, the stem is the tens place, and the leaves are the ones place. So this row is equivalent to saying we have 10, 13, 17, and 19. Right here we have 20, 21, 24, and 24. Right here we just have 35. And right here we have 42. Now we're trying to figure out on average, remember this is a key word for mean. Which school sold the most reusable bags? So our hint, find the mean of both. I'm going to find the mean for Roosevelt. After I do that, I want you to use it to find the mean for Madison. And then tell me which school sold more reusable bags. So now to find the mean, we add up all of our data points and divide by the total number used. So let's add these up. Let me grab a calculator. So we add 10 plus 13 plus 17 plus 19 plus 20 plus 21 plus 24 plus 24 plus 35 plus 42. So what I just did was I added up all of these numbers, and that total comes to 225. But remember, to find the mean, we have to divide by the total number of data items. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I divide by 10, and I get that the mean for Roosevelt is 22.5. Now what you need to do is find the mean for Madison and then say which one sold more. Whichever group had the higher mean is going to be the group that sold the most reusable bags. Okay, on example 2, we have some dot plots. These are the same as line plots. And we have a visual comparison. We need to know what they tell us about the average heights of the sunflowers. Okay, so first thing we need to do is find the median and the lower quartile and the upper quartile. And then we're going to talk about the IQR of the data. So again, what I'm going to do is find the information for plot A, and then you are going to find the information for plot B, and you're going to compare the two plots, focusing on their variability. Now, as you can see, I've ordered my numbers from least to greatest for plot A, and I did this by looking at my dot plot. I have 3 24s because there are 3 dots above 24. That means 24 happened 3 times in the data. So I put them in order from least to greatest, and now I need to find our median. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. All right, so I've got to find the middle numbers. So 1, 2, 3, 4, 5. Well, these two numbers are in the middle. So halfway between 25 and 26 is 25.5. And I did that by adding the two and dividing by 2 to find the average of those two middle numbers. So I'm going to put a box around my median. I can't use that now to find my lower and upper quartiles. To find your lower and upper quartiles, you find the median of the lower half of the data and the median of the upper half. We're going to start with the lower half. So I have 1, 2, 3, 4, 5. Notice I can use this 25 because this wasn't my median. All right, so with 5 numbers, I need to find the middle number, 1, 2, 3. So I'm going to circle that. My lower quartile is 24. Over here, 1, 2, 3, my upper quartile is 27. That's the median of the upper half of the numbers. So now this is my minimum, and this is my maximum. And I can now draw my box plot. So I drew a number line, and I plotted my key points for my box plot. My minimum was 24. My lower quartile is also 24, which is why I don't have a whisker down on this end. My median was 25 and a half, so I put this about halfway between 25 and 26. It'd probably be a little bit over. My upper quartile was 27, my third quartile, and then my maximum was 31. So what this box plot shows us is that most of our data is from 27 and below, and the 31 could maybe be an outlier. It's a little bit further away from the rest of the data. Now what you're going to do is the same thing I just did here for plot A, for plot B. And you're going to tell me, comparing the IQRs, the interquartile range, so the IQR for this would be 27 minus 24, which equals 3. If plot B has a larger IQR, it is more variable than plot A. It's not as consistent. If it has a lower IQR, that means it's more predictable and it has less variability. So whichever one is the larger interquartile range is going to be more variable. Okay, so now we're going to talk about using the data to make predictions. We can use it to make predictions if and only if our sample is representative of the population, meaning it doesn't show bias. So 3 things we have to ask ourselves. How big is the sample? Really small is not good. Who conducted the sample? Is there any potential for bias? And is it reasonable to use the data to make predictions? So if these first 2 are good, if we can check both of these off, then we're okay to say our data is reasonable. So our key phrase we need to use is the sample provides a reasonable prediction. We can never say our sample is 100% or we're 100% certain, but we can say that the sample, if it's a good sample, that it provides a reasonable prediction. Okay, so in this example, there are 60 students who take band classes at Mr. Tempo's school. Mr. Tempo surveyed 10 to find out how long they practice their instruments each day. The survey was randomly distributed. Random is a good word. Randomly distributed. And it was anonymous. These are both good things. Here are the results below. So first thing we need to do is find the mean time for the sample. So what we're going to do is add up all of the minutes practiced. So essentially, we're putting plus signs. We're adding all of these up. And because he said we surveyed 10 students, we know we're going to divide this whole amount by 10 to find our mean. So let's find our mean. When we add the total minutes from the sample together, we get 270. We divide this by 10 since we surveyed 10 random anonymous students, and we get that our mean practice time is 27 minutes. We can come over here and check, and we are correct. Now we're going to predict the mean for all students. How we're going to make a prediction is we use 10 out of 60 students, so that's about 1/6. That's a pretty good sample size. It was random and anonymous, so that Mr. Tempo didn't pick favorites. He picked the best and the worst, and he doesn't even know their names. So they could be his favorite students or least favorite students, we don't know. So yes, this leads us to make a prediction that each student, maybe on average, practices about 27 minutes. So notice we used our mean, and we used that to make a prediction that we think on average all of his players practice 27 minutes. And is this prediction reasonable? Again, it is, because our sample size was large enough and it was representative. It was random and anonymous. Now, using the data to make a box and whisker plot. So first thing we got to do is order our data from least to greatest. This is just extra practice making box and whisker plots. So you see, I ordered my numbers from least to greatest. Okay, I know my minimum is going to be 12. I can go ahead and plot that. And I see my maximum is going to be 36, so I can go ahead and plot that number as well. Well, now we need to find the median, the lower quartile, and the upper quartile. We have 1, 2, 3, 4, 5, 6, 7 numbers. So we find the middle number, which is 24. This is our median. We can go ahead and plot that point. Now we define the median of the lower half of the data for our lower quartile, or our Q1. Our middle number is 18, so that is my lower quartile. And the upper half of the data, the median, is 35. This is my upper quartile. That's about right here. Notice I did not use the middle number, the median, when finding the lower and the upper quartiles. Now all we do is put a line through our lower quartile, our median, and our upper quartile. And we connect the three lines to form the box part of our box plot. Now we connect the whiskers. I can put a line to make this look more like a whisker. I can put a line here. So what we see is the lower part, this first quartile, has more variability. It's more spread out than the upper quartile. And we could say 25% of the data is below 18. 50% of the data is below 24. 75% of the data is below 35, our third quartile. And we can even say 25% of the data is above 35. Because remember, no matter how big or small these sections are, each section of the box plot is worth 25%. So this is our first quartile. And hold on a second, let me erase this. From here down represents our first quartile, so this whole section. From the median down represents the second quartile. Our third quartile is the right half of the box, and our fourth quartile is the upper whisker. I hope you find this useful with solving the examples in your notes. Please complete everything that you didn't do in class and bring them ready to go tomorrow.